A polynomial is an algebraic expression that is the sum of the terms that are numbers, variables, and then the products of those numbers and variables. Okay, so that's the first thing here. We're talking about polynomials. Okay, what does poly mean? Anybody know? More than one. Good, it's many. It stands for many. Okay, and then we're going to be talking about numbers and variables. So give me some numbers here. 5. What else? 6. 13? Okay, 5, 6, and 13 I heard. Okay, here are some numbers. Okay, these are actually going to be called constants later we'll talk about. And then some variables. What are some variables? X. What? D. E. What else? Y. Good. Okay, so here are some variables. Variables are just letters that represent unknowns. Okay, so we're going to take the product of these numbers and these variables here. 5 times x is 5x, right? 6e and 13y. Okay, now these individuals here are called terms. Okay, so 5x is a term, 6e is a term, and 13y is a term. Okay, these expressions are called terms. Okay, now, eventually we're going to add these up to create a polynomial. Okay, but these are individual terms within the polynomial. Any questions on that? Okay, so when it comes to naming polynomials, we have monomials, binomials, and trinomials. What does mono mean? 1. Okay, so a monomial is polynomial with just one term. Oh, that's a funky one. Try that again. Which is one term. Okay, so some examples of this are 7x and negative 2mn. Okay, even though that has 2 variables, it's just one term because they're all together. They're not separated by anything. Okay, questions on that? Okay, what does bi mean? 2. Okay, so a binomial has 2 terms. Okay, some examples of this are 2x plus 1. Okay, this is a term, and then 2x is a term, and 1 is a term. Or 2mn plus 5n. Okay, once again, this is a term, 2mn, and 5n is a term. Okay, so it's 2 different terms. Questions on that? Okay. A trinomial. What does tri mean? 3. Okay. So a trinomial has 3 terms. Some examples of this are actually what we just took a test on, which is 2x squared plus x plus 1. Okay. 2x squared plus x plus 1. What is this called? What type of function is this? A quadratic. Good. So there's a squared here. Good. Okay. Another example of this is 3xy plus 4y plus 7x. Okay. So this has 3 different terms. So it is a trinomial. Questions on this? Okay, so now we're going to be talking about degree of monomials. Okay, so monomial is one term, just one term. Okay, so the degree of the monomial is the sum of all the exponents associated with each variable. Right? Now this is going to be a little bit different than the next page, so make sure you're paying attention here. Okay, so if you have more than one variable, you add the exponents. So for example, over here, 3x squared, Okay, this is one term, so it's a monomial. All of these are one term only. What is the degree of this term? 2. Good. Okay, it is my exponent, or the sum of the exponents. Okay, 5x, what is the degree of this term? 1, right? There's a little invisible 1 there. Okay, what is the degree of 7? 0. Good. There's no exponent and there's no variable. So just 0. There's a 1 there, right? Like an invisible 1. Alright. Now here we have m squared and n to the 7th. What is the degree of this one? It is 9. How did you do that, Krish? Good. So they say here the degree of the monomial is the sum of all the exponents. That means we add the exponents associated with each variable. So this is in one term. It's a monomial, so I'm going to do 7 plus 2. The degree of this term here is 9. Okay? Good. So what is the degree of x, y to the 4th, z to the 5th? 10. Good. Why 10, Jonathan? Why not 9?
Because the x has an exponent.
Good. There's 5 and 4 here, but this x also has a 1 here. Okay, so it's 4 plus 5 plus 1, which is 10. Great. Any questions? Okay, so the next page says the degree of polynomial. So now we're talking about more than one term. Okay, so we do the same thing, it's just a little bit different. The degree of a polynomial is the same as the degree of the monomial, but we pick the highest degree. Okay, so we find the degree of each one and then we pick the highest one. So, for example, down here, okay, what is the degree of 8? 0. And what is the degree of negative x? 1. What is the highest degree? 1. Okay, so that's the question you're asking yourself here. What is the highest degree out of all of them, out of each monomial? Okay, so here, my 7x to the 4th, what is the degree here? 4. What is the degree of 5x? 1. And what is the degree of negative 3? 0. So what is my highest? 4. Okay. Now what happened to adding, Miss Cullen? That still happens here, okay? But notice the difference between this is a monomial. I can add within the monomial. I cannot add across. This negative and this plus, okay? Think of those as roadblocks. They say you cannot add my exponents over here with the exponents over here. Okay, this is a monomial. It's one term. So here I'm going to add 3 and 2. What is the degree of this monomial? 5. And what is the degree of this monomial? 3, because there's a 1 here. So what is the highest degree? 5. Questions on that? I cannot add these two together because they're separated by this subtraction sign. This is a term and this is a term. You can only add within your term. Does that make sense? Okay, cool. Come down here. What is the degree of this term? 5. Good. 2 plus 2 plus 1 is 5. What is the degree of this term? 7. 2 plus 2 is 4, plus 3 is 7. And what is the degree of this term? 2. So what is my highest degree? 7. So that's the degree of the polynomial. Questions on that? All right, come down here. Here we are naming them. Okay? So, for example, this first one here, What is the name of this? It has two terms. So what is the name? Good. This is a binomial. And then they want to know the degree. Well, what's the degree of this first term here? 2. And what's the degree of this? 0. So what is my highest degree? 2. Questions on that? Let's do 2 more here. Let's come here. What is this called? Be careful, I'm hearing trinomial. Is this 3 different terms? Terms are separated by subtraction and addition signs. Do we see any of that here? No, this is just one term, guys. This is a monomial. Even though it has 3 variables, it is only one term. It is not separated. Okay, so this is actually a monomial. What is my degree here? There's only one degree. What is it? Not 2. The y has a 1 and the z has a 1. It is only one term, so we can add these. What is my degree? 4. Questions on that? Do we see the difference of it being separated? So, for example, the next one down here. This is a trinomial because it is separated by subtraction and addition. It is 3 different terms. Do you see the difference between this and this? Okay, this is a term, this is a term, and this is a term. This is just one term. Okay, so what is my highest degree in this one, in this trinomial? This has 2, this has 2, and this has 2, which means my highest degree is 2. Questions on that? You guys are going to fill out the other ones. Okay. What does it mean to be like terms? They have the same what? Same variables. Okay, or now we can call it as same term. Okay. So here's an example, 3x squared y and negative 5x squared y. Are these like terms? Yes, right? They both have x squared y. Okay, so now we're going to get into adding and subtracting polynomials. To add or subtract, just like we have before, you need like terms. That means you need the same variables or the same type of term. Okay, so here these have the same variables raised to the same power or degree. Okay, so this can be simplified to what? What is 3x squared y minus 5x squared y? Negative 2x squared y. Okay, so when we're adding, we keep the variables the same, and we combine the numbers or the coefficients. Okay, so you do not touch the variables when you are adding and subtracting, only when you are multiplying. Okay, so we are not going to do anything to x squared y, we just want to look at the coefficients in front. Questions on that? Okay, turn the page. Okay, so what are variables? We know that variables are letters that represent unknowns. Okay? Variables are letters that represent unknowns. So what are the variables in this problem up here that they're given to us? Good, a and n. Okay? We know that. We know variables are letters that represent unknowns. Constants. Constants are just the numbers by themselves. Okay, so it's just a number by itself. Okay, it does not have any variable attached to it, nothing. What are the constants in this problem? 16, negative 30, and 50. Good. Whereas coefficients are numbers that are attached to a variable. They are the numbers in front of the variable. Okay? So being multiplied. So given this problem, what are the coefficients here? Good, negative 10a, negative 9n, 3n, and 15a. Come on down to adding here. Okay? Now, I'm going to show you something that I find helps combine like terms, especially when you're given a lot of them. Okay? Now, some people like to use different colors. You can do that. Or I like to use shapes because math is awesome and it's full of shapes. Okay? So, real quick, I'm going to show you something here. What I do as I'm going through these problems is I look for things that look alike. Okay, so I come here and I see, okay, here's a negative 14xy squared. I'm going to box this. Okay? Make a rectangle around it. Then I'm going to come here and I'm going to find anything else that has xy squared. Where else do I see xy squared? Right here. I'm going to make sure I get the plus or addition sign in there with it. Okay? Do I see any more xy squareds? Nope. Okay, cool. I'm going to move on to a different shape. So I'm going to come here and I'm going to say, okay, I see a 10xy. I'm going to look for any other xy's and I'm going to circle them. Here's another one. I'm going to circle them. Okay. All right, I'm going to move on. My next one, I'm going to give, let's do a triangle. Triangles are fun. Here's a negative 5y. It's kind of a triangle. Or like a teepee hut. Or a kiss. Okay? There's y's. Those can go together. And then I'm just going to underline my other ones. Or use different colors. Okay? Why do I do this? I'm a very visual person, and this just kind of gives me the visual of what's going to go together. Okay? Once you have this, you do not need to worry about the variables. Now I just want to deal with the coefficients, or the numbers in front of the variables. I'm going to combine them. So for example here, I'm going to combine negative 14 and 17. Everything in my boxes I'm going to combine. So negative 14 plus 17 is what? 3. And then I'm going to write the variables associated in that box, xy squared. I'm not going to do anything to them. I'm just combining the like coefficients. Questions on that? All right, then my next thing I did was my circles, so I'm going to combine those, and I'm just going to look at the coefficients. 10 and negative 13. What is 10 minus 13? Okay, so I have a negative 3, and I'm just going to write xy, the variables associated with my circle. Next, I'm going to come to my triangle. I have negative 5 and negative 2. Make sure you include those negatives. So I have negative what? Negative 7, and I'm going to bring my variable y with. And lastly, I have my constants here. I have 8 minus 3. What is 8 minus 3? 5. Bam. I have all my like terms together. Okay, nothing else can be combined, and that's it. All right, now, how many terms does this have? I'm going to trick you a little bit. How many, not trick you, but add a little thing here for you. How many terms does this have?
4.
4 terms. Okay, what's my degree? Okay, what's my degree for this first term here? 3. Include that. What's this? 2, 1, 0. What's my degree, guys? 3. You pick the highest one. Okay? This is called a polynomial because there's more. If you go over 3, it's just a polynomial. Okay? So I'm going to do the same thing down here. Now, these are in parentheses. Sometimes parentheses matter. They matter if this is a negative that I have to distribute that negative and make everything opposite here, or it matters if there's a number outside of the parentheses, then you have to distribute that before you do anything. But here, there's nothing outside of this parentheses, so I can actually just come and start doing the same thing I did before. Combine my A's. I have a 5A here. Where else do I see an A? Right here, 11A. Okay. Then I'm going to come do my circles. 7BC. Where else do I see BC? Right here, negative 13. I make sure to get that negative in there. Okay. B squared. Where else do I see a B squared? Right here. And lastly, my constants. I'm going to get those all together. Okay, then you can tell me the degree and how many terms. Okay. One last thing I want to add here. When it comes to your homework, okay, you have a problem, number 9, that looks like this. Okay, you have problems where you do have a number outside. So take a glance at page 7 real quick. Okay, this is number 9 on page 7. You have this negative 7 outside your parentheses. You must distribute it before you combine your like terms. If you look at number 7 on page 7, there's nothing outside of the parentheses, so you can just start combining your like terms. But if there's a negative, there's a number, you have to distribute first. Okay? I hope that helps. Your homework is page 6 and 7. And finish this up.